Hello YouTube, this is Eli the OBD Tech. I'm here working on a 2004 Dodge Ram 1500 with the 4.7 liter engine. Customer complains that the check engine light is on. So the first step to this process is to check the codes on this check engine light. So here we go, guys. I'm here using my Autobots V30 scan tool. So I'm going to check the codes on this vehicle. I see we have a P0456 evaporative emission system minor leak. So in other words, a very small leak. Status of a common causes: vacuum leaks, faulty evaporative emission system, faulty loose emission fuel cap, faulty fuel tank pressure sensor. It seems that we have another code stored. So it's a P0440 evaporative emission system malfunction. Status: vacuum leaks, faulty evaporative emission system, faulty fuel tank pressure sensor, faulty. So on this diagnosis, I'm gonna attack the P0456 since this code is telling us a specific problem, which is a minor leak in the system, versus this P0440, which is telling that there's a malfunction somewhere in the evap system. And most of the time, this P0440 is there alongside with another code in which we have this P0456. But I'm still gonna warn the customer that there's maybe a possibility, once I find the problem and fix it, that this P0440 may come back, and it may come back alongside another code, but I'm not sure. This customer has to drive the truck, maybe days or weeks. But if this P044 comes back, I will make another video on diagnosing this evaporative emission system malfunction. So the first step to the diagnosis, I'm going to do some visual inspections on the fuel cap, and also some visual inspections on the evap system hoses, on the engine bay, and also on the evap canister, which is located beneath the truck, and also look at the hoses under there. So let's begin with this diagnosis, guys. Before we begin the visual inspection, I wanted to show you guys the possible causes of this P0456 code. Right here on the manual, it says that the possible causes could be due to good trip equal to 0, leak at gas cap, vehicle history and service bulletin investigation, visual and physical inspection, verify evaporative emissions leak, evap purge solenoid operation, evaporative emissions leak detection, gas cap, or the NVLD, which is natural vacuum leak detector. So these are the possible causes of this P0456. So let's go back to the truck. So I'm here at the fuel tank's fuel cap. I'm going to start by doing a visual inspection on this fuel cap. It looks fairly new. I guess the customer did replace this fuel cap with the new one, because the seal looks in good condition. I don't see no cracks. I don't see no damage to this fuel cap. So for now, I'll say this fuel cap is not the cause of this P0456 small leak. So next, I'm going to take you to the engine bay and take a look, and also take a look at the evap hoses to see if they're disconnected, cracked, or brittle. So right here, I'm showing you guys the evap purge solenoid, which is right here. This is this connector. It's a 2-wire solenoid, and this solenoid, this evap purge solenoid, it has 2 hoses connected to it. I see that they're also plastic and rubber. So it seems that these 2 rubber hoses are in good condition. I don't see no cracks, and they don't feel to be brittle, so which is good. And over here, there's more hoses, attached to this plastic hoses. These little I guess 1-inch hoses also look good. You know, they don't look brittle. I don't see no cracks. So I'll say from here, you know, the system is okay. And now I'm gonna take it to the throttle body port, which is right here. This one, which is the upper hose right here. This one runs to the throttle body, and I see that this throttle body also has a rubber hose attached to a plastic hose. From here, it looks in good condition. It's not brittle. I don't feel no cracks. And then on the service port hose, this one actually runs all the way to the Evap canister. So I'll say, so the next visual inspection will have to be at the Evap canister, and also take a look at those hoses. But I also see another connection here. This L-shaped type rubber hose. This one also looks good, which this one actually runs to that, you know, to that throttle body port right there. It doesn't feel brittle. I don't feel no cracks to it. So I'll say this visual inspection here at the engine bay is pretty much good. So I'm going to take it to the Evap canister, which is below the truck. So we're here at the Evap canister, which is right here, guys. I see some hoses. I see the natural vacuum leak detector, which is right here. It's a solenoid slash switch. The hoses, you know, that run to this Evap canister, they look in good, you know, they seem to be in good condition. You know, they don't seem to be brittle. There's just a filter to this Evap vent side. I also see some other plastic hoses attached to it. It is a smaller line. This hose runs all the way to, I guess, to the fuel tank. So from here, this Evap canister system looks in good condition. Here's another hose right here. This actually runs to the vent filter. And this hose right here with this check valve, that's the one that runs to the Evap perch solenoid on that service port hose. So let's say visually this Evap canister looks in good condition. So the next step is to do some bidirectional control on this perch solenoid to see if it's functioning properly. And I'll also do some voltage checks and also do a vacuum check on that solenoid to see if it's holding vacuum or not. So that's the next step, guys. Alright guys, you know, so I'm here looking at the Evap perch solenoid wiring diagram. I see that there's a Evap perch control and an Evap perch return. And just by looking at the circuit, I cannot tell if this is a power side switch or ground side switch solenoid. So I'm gonna do some voltage checks with my voltmeter. If both wires show 0 and 0 volts, it means it's a power side switch. If it shows 12 and 12, it's a ground side switch. So I see that there's a dark blue with white and a dark blue with brown. The dark blue with brown is the Evap perch return, and the dark blue with white is the Evap perch control. So let's go to the sensor and do some voltage checks. So this is my voltmeter. I have my voltmeter already set up. I have the negative lead to the negative battery post and the positive lead to the solenoid's control wire, which is the dark blue with white. The key is on, and the reference voltage that is showing is 0 volts. So next one will be the dark blue with brown, and see what voltage it shows. It's also showing as 0 volts reference here. So it means this solenoid is being controlled as a power side switch, meaning that the computer is providing the voltage to the solenoid. So the next step is to do some bidirectional control with my scan tool and see if the computer is providing the control signal to this dark blue with white. So so I have it connected to the dark blue with white. I'm gonna go to my scan tool. So that's the voltmeter already set up right there. So so we're here at my scan tool. I'm gonna go to the Evap solenoid. So over here we have the test already set up. So it says that the engine must not be running. So I'm gonna go ahead and hit the start button, but I'm gonna show you guys the voltage on the voltmeter while I do that. So right now, like I said, it's a 0 volt reference on that blue with dark blue with white control wire. So, so I'm gonna go ahead and press start and see what happens. As you can see, this voltage did vary, which tells us that this solenoid is this circuit, it's a pulse width modulated. So which means that the ground side will also be controlled. So the voltage on the ground side will vary too. So next step is to go to the dark blue with brown. So right now the dark blue with brown, which is our return signal, is also showing 0 volts. Like I said earlier, this is a power side switch circuit. So I'm gonna go ahead and hit the start button again and see what this return wire gives us. As you can see, it gave us the max voltage was 0.42, but it did also vary. So like I said, this solenoid is being controlled pulse width modulated, so the ground side would also vary. In other words, don't expect a ground side voltage of 100 millivolts or less. So this shows that this computer is providing the power and ground. So the next step is to do the vacuum test on the solenoid to see if it's holding vacuum. Alright, so on this test, I'm going to perform a vacuum test on this per solenoid. On the repair manual, it said to apply 10 inches of vacuum, and this vacuum should hold 15 seconds or more. And if it doesn't hold vacuum, means that the internal side of this solenoid it's basically bad. The valve seal is not, it's not holding vacuum anymore, so it's leaking through the seal. So I'm gonna apply the 10 inches. See what happens. Alright, so so I apply the 10 inches of vacuum. As you can see, the vacuum is bleeding off slowly. So this pretty much means that this solenoid is internally bad. Electronically, it is functioning properly, but mechanically it's not holding pressure vacuum anymore. So this means I'll have to make a trip to the auto parts and get a new solenoid. So once I get this new solenoid, I will perform the same test and show you guys how a good working solenoid should function. So so I'm gonna apply this vacuum one more time just to make sure. As you can see, it's still bleeding off slowly, but it is bleeding off. Alright guys, so this confirms that this solenoid is leaking internally. So alright guys, so after a trip to the auto parts, I was able to get a new per solenoid. I already have it set up with the voltmeter and the vacuum pump, and that's the old Evap per solenoid, which was not holding vacuum anymore. Alright, so I'm gonna perform these tests to this new per solenoid and show you guys how a good working solenoid should function. So I'm gonna start by doing the the bidirectional control with the scan tool. So so I already have my voltmeter connected to the control wire, which is the dark blue with white. So let's begin. By checking the control wire to this Evap solenoid. So here's my scan tool. I'm gonna hit the start, and let's watch the voltmeter. Here we go. As you can see, the scan tool already commanded this pulse width modulation voltage, which it was varying. I'm gonna hit it one more time. As you can see, it's varying right there. The highs was 5.56. So it's basically the same voltage as the other sensor. Now I'm gonna go do the second wire, which is dark blue with brown, and check the return signal. So I'm gonna back probe it. Now let's look at the voltage on the ground side, on the control side of it now. So so we should expect the same voltage as we did with the defective solenoid. So so I'm gonna hit start, and let's watch the voltage on this voltmeter. As you can see, the highest reading was 0.44, and then dropped back to 0, which was also varying. As I said, the computer is also controlling the ground side, which is pulse width modulated. I'm gonna hit it one more time. You see, the voltage was varying again. For example, if this Evap per solenoid circuit was not pulse width modulated, this ground side should have been 100 millivolts or less. But since this circuit is pulse width modulated, this voltage is going to be higher than 100 millivolts. But the next step now, I'm going to show you guys the the vacuum test. I already showed you the electrical side of this. Now the vacuum test, and I'll show you guys how this a good working Evap per solenoid should hold vacuum. Now, like I said, I'm gonna apply those 10 inches of vacuum, and this vacuum should hold 50 seconds or more. So here we go. I had a little bit above 10 inches of vacuum, but this vacuum should hold 15 seconds or more. So as you can see, this vacuum is holding. And this just confirms that the old Evap per solenoid was not holding vacuum anymore, compared to this new one here. Still at a little bit above 10. I'm gonna reset it and apply it one more time and perform this test, just to confirm. There we go. By the 10 inches, as you can see, it is holding vacuum. So I'm pretty sure, and I'm also confident that this P0456 was the cause of this defective Evap per solenoid, which was electronically it was working, but mechanically it was not holding vacuum anymore. So I'm pretty sure this is a fix. This P0456 should not come back, but I'm still going to confirm that the system has no more leaks by doing a evap system leak down test by using my evap leak tester. So this is just going to confirm that the system has no more leaks. So stay tuned and watch part 2 of this evap diagnosis. Alright, thank you for watching. Subscribe if you like. Thanks. I forgot to show you guys this, this final procedure by using my scan tool with the, with the vacuum pump. I'm gonna apply this, those 10 inches of vacuum to this Evap solenoid, and then I'm gonna command the Evap solenoid to open with my scan tool. So this 10 inches of vacuum should drop to 0 once I command the scan tool to energize the solenoid to open. So let's go to the scan tool. I'm gonna hit start and command the solenoid to open. So here you go. Now testing complete. I heard the solenoid click, and as you can see, the 10 inches of vacuum did drop to 0. I'm gonna do it one more time just to confirm. So we have 10 inches of vacuum. I'm gonna go back to the scan tool and command it to open. This vacuum should drop again. Now testing, test complete. Back to the vacuum gauge, and we had 0 vacuum again. So this is just I'm just showing you how this evap solenoid should function when the computer commands this solenoid to open. So so thanks for watching, and stay tuned for this part 2 of this evap diagnosis.